Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. Okay, keep watch forward, you will understand very clearly. In the previous video, we discussed about work kinetic energy theorem. Okay, work done equal to change in kinetic energy, we have done derivation. Now we are going to do the relation between potential energy and the work done. Okay, from the conservation of total energy. Energy is conserved. You cannot create the energy, you cannot destroy the energy. Energy will transform from one form to another form. Okay? So, the total energy means kinetic energy plus potential energy. So, this object I am leaving, here it has some energy, that is potential energy. So, after that, this potential energy is converting or transforming into kinetic energy because it is moving with some velocity. But from where this potential energy is coming, that I will give you some example. Okay. So why it is falling down? That is due to the gravity. Okay. Because we are staying on the earth. Earth has mass. Because of mass it has some gravitational field. So this object also has a mass. Earth is attracting this mass. That is why it is falling down. Okay. So because of the force between these two masses, these objects are moving. That is the reason the virtue of its position, the energy change. From here it possesses some energy, here it possesses some other energy. Okay. So here the potential energy is less compared to potential energy at this point, because as you are going away from the earth, okay, as you are going away from the earth, the potential energy is increasing. So this energy possessed by virtue of its position, that is called potential energy. Okay. Now we are going to derive this relation, that is between work done and the initial potential energy and final potential energy. Keep watch forward, you will understand. This is class number 76. Potential energy. Energy possessed by an object due to virtue of its position is called potential energy. I am using a symbol or a letter, that is U. For kinetic energy I am using K. For potential energy I am using U. See here, this is earth. The mass of the earth is capital M. Suppose one object is at a height of h. The mass is small m from the earth's surface. Okay. Then what is the energy possessed by this object? This object is rest with respect to earth, but it is at a distance of or a height of h meter. Okay. This h is much smaller than radius of earth. Why I am taking this? The gravitational constant G should be constant, because if h is small, G I am assuming on the surface is equal to G at a height h. That is the reason I am using this approximation. The height is less than r. H is much less than radius of earth. So the potential energy possessed by the small object of mass small m is mgh. R is radius of earth, h is height, g is acceleration due to gravity. Okay. Total energy equal to kinetic energy plus potential energy. Okay. I can write E equal to K plus U. K is kinetic energy plus U is potential energy. From the conservation of energy, energy cannot be created, cannot be destroyed. Energy can change from one form to another. Simple example, you are throwing a ball upward. As it is moving up, kinetic energy decreasing, potential energy is increasing. Means kinetic energy converting into potential energy. This. After reaching maximum height, it is coming back, no?
So potential energy converting into kinetic energy. Like this. You got it? See here, the total energy is conserved. So E equal to final kinetic energy plus final potential energy equal to initial kinetic energy plus initial potential energy. This is equation 1 I am calling. From work kinetic energy theorem, W work done equal to final kinetic energy minus initial kinetic energy, that is del K. So from equation 1 we can write this Kf minus Ki equal to Ui minus Uf. Okay, so W work done in the form of potential energy, how we can write Ui minus Uf. Be careful what I am telling. Here final kinetic energy minus initial kinetic energy is work done. But in terms of potential energy, work done equal to initial potential energy minus final potential energy. So what I can write here, minus, you take the common. So UF minus UI, final potential energy minus initial potential energy. This is nothing but del U. So work done, W equal to minus del U equal to del K. This is most important equation we will use for solving the problems. You got it now?
Please like this video, share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos.